All right, all right, all right. Let's see. Someone can see me. Let's see. Hey, what's up, man? How are you? Can you hear me? I'm gonna be working editing a job that I have to do, and I decide to do this in the. Yes, sir, man. They are in California right now. They are in California since the day 21. Let me change. Give me 1 second. Let me change the so you can see me. Let me minimize that. That's what I'm doing. Yeah, they are in the Port of California since the day 21, and they are in the status of waiting for. It says that they are currently being inspected. So this can be in any moment. I mean, they can release that tomorrow. They can be today. I mean, 1 week from now, 2 weeks from now. I mean, it's unknown how much custom takes. So what I know is as soon as they release that, it's 4 days for FedEx to ship it to my location. And as soon as FedEx ship that, man, I mean, I ship that. I'm just gonna take just 1 day to check everything is in good order, and then start shipping. That's quickly. So if you go to the website, I stop the pre-orders because it's not fair for the people that put the pre-order, you know, that they keep going pre-ordering or stuff like that. So I stop it. I'm gonna wait until they arrive, and actually the price went up already. So the people that pre-order, they got the good pricing. Even if they bought in quantity, they got even better pricing. So the leftover of the sales are gonna be in that price. There's no discount, in the other one. So I want to give the be fair with everybody that you know did the pre-order. So you bought 70. Nice. Yeah, man. As soon as they arrive, from you a pre-order to build an e-bike. Super happy to know this, man. Thanks from Italy. Nice, nice. Yeah, man. Um, Let me show you what I'm gonna be doing. I'm gonna be working here. I don't know if you guys can see this. I have a client battery that I'm working with, which is. Let me see if it's this one. I'm not sure if it's this one or not. Let's see. You guys can see this. So maybe this is a boring topic for some people, but that's how I build my designs in Tinkercad. See, right now I need to build the top side, which is gonna be this one, but in this style. I have this style already printed. Uh, Let me show you in the. Let me switch. Where I switch. Sorry, I have time. I don't play with this, and let's see. So you can see the two screens, right? Let me put this like this. All right. one by one. There we go. Let me show you something quickly here. You know what? Let me take out the that background from the back, so virtual background, so you can see better. There we go. Yeah. Let me show you something. Give me 1 second. I have something weird here. So, all right. It's gonna be calibrating now. Where did I put it? Here. This is what do you see that they're printed already. See, I have already a few cells inside just as a testing. So that basically is what you see in the screen already printed. So I have actually two of those. So I have the two first stories already printed. That's gonna be like a tray dash. Let me show you one open. What I got? See, that's what do you see there? So I print that already. That's for 21,700 cells. That's 18 cells in each line. So, or if you put it, six between here and here, one, two, three, yeah, and that's gonna be 2p. So that's what I'm making. These one are already built. I'm printed, ready to go. So I still need to print the top layer, which is one less. Uh, Actually, not only print it, I need to build it. I'm gonna build this now. I need to make it this one that you see on top. That's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It needs to be 16. So what I do here, see, this is what I have already. This one is a design that I'm not gonna use. This one is the keeper. So let me change this color to work more comfortable. So what I do first of all is duplicate this. I'm gonna leave that untouched because that's gonna be my main design. So this is the one I'm gonna work with, and I need from the 18. I need only 16. I'm gonna be switching to make sure I can read everybody's. So what I do here is, for example, I'm gonna break this design. So I take out that part, and then I need to break this again. Very easy. I mean, in the way that I do it, see, that's broken already. And I need to eliminate two of those lines, pretty much. So, so the last line, I eliminate all this. Let's see what else. I guess I need to add here. Maybe not. Let's see. Otherwise, it's not gonna look very well. What I'm going to do is, let's see. I need to break this again. Let me make some space here. So we need. Let me see how long is. It's 371. So let me break this, and then what I do is let me lock this to make sure I'm not messing up absolutely anything. So now I need to break this again. Let me make sure I read everybody. I know this part is voting. Maybe, I mean, that's not for everybody. How many people we have here? Two. So, but that's the ugly part, how I call it. I mean, I like it. I really like do what I'm doing here. So you know what? I'm gonna duplicate this as well. just in case I need any piece of this. Put it here. Let me put it farther there, because now I'm gonna break this. Boom, boom. Because I need to re-break this again. There we go. And now I need to match this size, which is gonna be what, 371 plus the corners. So it's gonna be 371, 371.2, I believe that it was 371.2. Let me double check again. 371.2. Yep. So that one is this one. So and actually I need to, these one are the same ones. So what I do is select this four. You know what? Temporarily, I'm gonna make this in one piece. Let's see. Let's make it one piece for the moment. If someone have a question, just throw it. Okay, nice. That spacer enclosure should be implemented for the one of some phase charging material that keep thermal consistency. Yeah. Yep. Uh yes. Let me show you something. Let me show you something. There's few materials that many people doesn't know that they are thermal conductive. Thermal conductive. And I'm gonna share this in, let me open Amazon here. And give me 1 second. I'm gonna show you something. Is this? Um, Let me share this. Check it out. This is a material that you can 3D print, and it's thermal conductive. It's made to do like, see, you can make like trays, and then you make those. Look at how cool those fins, and that act as a cooler. Look at this. You can make fins, and it's thermally conductive. All that. So that's an option. But look at the price. How much costs that filament? $149. I'm planning on get few of those for special projects, so I can help with the thermal conductive part. So that's pretty cool. Let me put it back in Tinkercad. There we go. We're here. Okay, now I need to connect this and this together, which is gonna be. Let me move this from here. In the way that I do this, I put this here, right? And then I go here and I tell you're gonna be attached to here. Oops, let me. This is gonna be attached to here. And then I select this. Boom. Oh, that's weird. Why did that? It should not do that. Do this again. Okay, this is the floor. Wait. There. Should not do that. Okay. This is here. And this, if I press D, there we go. That's what it's supposed to do. So let me do the same thing in the other side. Here, select this, and it's attached. And then now to align that, I select both. Click this tool, select the one that is going to be the master, and select the center, which is here. Now that's centralized. Same thing in this side. Select here, and that's the center. Okay, now we have that centralized. Now I have to do the same thing with this, but what I do is measure between here and here. Now we have 374.20. So I'm gonna match that 374.20, right? Same with this 374, 374.20, right? And then one is gonna be in this side right here, and the other one is coming to this side. So I select this and go in here, right? Now we need to select, put this in the center, which I select here, this, this, and go to the center, centralize, same thing in this side, centralize, boom. Now we have that centralized. Now we need the center. So here I select this and lock, and then select this, the same story. Now this is gonna be one piece. Let me take out this from here. Let me make that in one piece first. One piece without affect the center. Yep, good. Now put this in here, selecting this, centralize in here, here, and here. Okay, now I have the first one. Now I need to create one in the center. So how I do this? Um, I have few ways to do it. I'm gonna clone this, change this setting to 5 millimeter, and I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14, 15, 16, I guess 17. No, 17. Yeah. So if I measure between here and here, we have how many? 115. So I'm gonna duplicate this again, and now I'm gonna put maybe there 113. What it says between here and here, 115, 115. So I need it closer. Boom, boom, boom. Let me see, 115. Now we match it. All right. So, but I need one more, I guess. Let me see. I need one in the center. So let me duplicate this. I need one here in the center. So it means that I'm gonna move this in between. Probably there. Yep. So duplicate one in the center right here and move this there. Probably. Let me make sure we have the same distance. 95. 110. Nope, one more. It should be 110, 95. So let me move maybe one more to the left. Yep, there. 90, 100, 95. So I can go one more. And this between here and here 90, between here and here 90, between here and here 100, between here and here 100. Yep. Okay, now I have set it up. I'm gonna hide this. I'm gonna make it one piece now. See? Now I put back the other part. Oops. Put everything back. And that's it. I guess we're good there. Um, I can do it like that. But I want the holes in the center. So what I'm gonna do is put it back. Actually, no, that one. This one is the one that I need back, like this. And now put everything in one piece. Yeah. Let me make sure I'm reading everybody's here. Hi man. I look at that thermal conductive filament. Yes, man, that's good. Let me share the link. Let me share the link with you guys. Um, this is the link from the thermal conductive. If you use that link, that helped me. I mean, it costs the same for you, and that helped me. Okay. Uh, what's up, everyone? Well, I'm doing the design for something that I have to work with. If you notice. So let me see how that goes. Let me change the color. Boom. I guess that's it. That's it. The only problem that I see here, I see a problem now. I need, maybe, let's see, maybe I need here one of these hole for, I can work like that. Let me see, one, two, three, four. Let's see, one, two, three, four is one boss bar. One, two, three, four. Four is another one. One, two, three, four. One, two, three, four. One, two, three, four. One, two, three, four. Okay. So, man, I will which have one of these holes here. So let me fix this. Let me fix this. What I'm gonna do, break it again. Let me disappear this. And then I need to select these two ones as make the one piece, duplicate this, and then put it right in between. There, that's what I need. And then repeat the same thing. Let me put the other one back. Perfect. I need one here. Actually, I don't need necessarily to disappear this. I can duplicate this, put it in here, and now centralize this, and boom. So the rest, I guess, is good. The rest is good. Now let me do the other side. You know what? I should do this side too. In here, let me disappear this. I'm gonna make one here. Let me break this again, and now this and this is gonna be one piece. Duplicate this. Actually, I don't need to duplicate it. I have two of them there. There. Ah, wrong. Let me duplicate that. There. Oops, wrong. That's the master. There we go. Now we are talking. Now let me break this again. And there was another one that I need to break. This one. We're good there. Man, it doesn't look symmetric. I should put one here too. It's gonna be a little bit different than the other ones, but okay. Let me fix this one too. I know this part is voting body, but um, that's the part of the design that we need to work with. That sometimes is not funny. Um, Let me break this, and this in one piece. What I'm doing, if you see, I'm joining these two ones to be able to make a center here. See, because if I don't do that, I cannot find the center. So and then I break it again, but that part is already in place. So there is an easy way to do this side without have to do everything again, but I'm gonna do it manually so you can see what I'm doing. So this and this, join it, duplicate this, select here, boom, boom, boom. and break it again because I don't want it in one piece. There is now one here in the center. Join these two ones. Select one, copy, select here, boom, boom, boom. Break that again. Buddy, and this is Tinkercad. Tinkercad is very, very simple. It's not powerful like Fusion 360, but I so fast in Tinkercad because I use this so much that I really like it. See, I have a boo boo here. Let me move this one. I cannot see this center very easy. There we go. Come on. There we go. That's what I need. And now break this again. Let me read the comments, okay? Let me read the comments. Okay, yeah, I think just gonna use. I'm gonna show what I'm reading. Okay, I think you're gonna go ASA for it. A thermal conductor was thermals. Yeah, I mean ASA is a really, really, really good material, buddy. I like it even more than ABS. I use ABS a lot. Um, what's happening? ASA is very, very difficult to weld. Due to the limitation of the use, I can really have a thermal pad connecting to the case, but that will be ideal. Well, that's for keep it warm. But the filament that I'm using is more. I mean, the one that I was mentioning is actually for cool down. Was the idea? Um, but I got a brand new glitter egg 11, nice, about a month ago, and haven't tested. I use it till today. The piece of crap blow holes in the. You must be using nickel, right, man? With nickel, you have to start 5%, 5%, very low, 2%. I mean, like that. Imagine it, buddy. Imagine it, the my goodness. Give me one second. I'm trying to. There we go. Imagine it, the A width that I use, which is where is my A width? Is somewhere here. We cannot see it. It's not in the screen. It's actually they have only the box. This is the goat, the 120. This beast, it's 69.2 kilowatts. This one, this one, different from the glitter. The glitter you use 5% stuff like that. A with I have to go with 0, 0, 1, and maximum of 0, 0, 2 from 999 gears. Uh, think about it. That's actually what less than 1% from the power. It's just ridiculous, buddy. It's ridiculous. Um, the glitter. You're welding with that. I'm reading the comments. Really? Point. You're welding point two, and you blow a hole in 20% with the. Let's see. Yeah. I mean that's excellent. I mean, if you use the thermal that I was showing you there with the aluminum case, oof, that's that's really cool. That's really cool. Believe me. All right, I'm gonna keep going here, okay? With the what I'm showing here. Um, where is here? Okay, I almost done here. I guess I have to do two more, okay? So basically, joining the two connections here, duplicating one of the shades. Selecting this, put it in the center. So I have to select this, boom. Now remove the connection and do the same thing with the last one. Join it. Actually, you have to do this one too. So duplicating, put it in the center, boom, breaking this again, and now let's make the last one. Okay, joining, duplicating the last one, and put it in the center. Boom. So why I did all that? Now you're gonna see. Now I put everything back, boom, like this, and now I join everything in one piece. It take time. See the memory. It's like freezing a little bit. It's the application, it's not the computer. It should be ready. It's still recovering from what I did. Let's wait until fully recover. Let me change the color. Come on, computer. Come on, come on, come on. It's working on it. It's still processing. In the meantime, let me check the printer. If you use like soldering paste, that will make more likely blowhole generate. Uh, for a whole pack like that, you will make want to use 100% infill change print direction of. Okay, yeah. For that one, let me show you. I'm gonna show everything that I'm gonna be doing. Okay, when this happen, when Tinkercad, we have two choices here. I can log off, get out of there, and then going back, which I guess is this one, the one that I was working with. Let's see. It was that one, right? Yep. Yep. Actually, it's still recovering, still loading. Technically, I can copy that already. So let me see what I did here. See, this is here. I don't need this anymore. Well, that was the original. Let me delete that one. So I have this one, which is the first copy, and now this is the second. Okay, so I have that ready, and it's gonna be ready for printing. Nice. Let's see how it's gonna look like. Yep. What I'm gonna do with this, because I'm gonna like, let me show you how I make a battery. Okay, I'm gonna present one battery here. So basically, I put one of these holes, make it completely round, right? And then I change. Let me put a ruler on the floor so I can see better. That's gonna be 21 by 21, right? That's the size of a battery, and then the height is 17. I'm sorry, 70. That's a battery, okay? The size. Now, what I do is go and put another layer here to make it look nice. It's gonna be what 0.1. No, actually, let's put it 0.2. Right, and then 15. No, 14, 14, and then we change that color to this. We wanna make it perfect. Actually, come on, perfectly round. Put this back here. Now centralize this. Boom, boom. And we have a battery. Right? Let me lock this. Boom. Not lock. I'm sorry. Join it. It's gonna change color. That's normal. Then to centralize this here, what I do is go back, break it, right? Then select one. I put it here. Boom, 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 and boom. We have the battery insert. Now I'm gonna duplicate this. Look at how cool is this. I'm gonna put one here and here. Now let me duplicate first. Duplicate the battery. Select here, 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 and now I do paste, 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 paste. All right. Now we have the batteries aligned here. Now, uh, for the next ones, um, right here, no, still like here. See, I'm duplicating, duplicate one, select only one here, duplicate, and I'm gonna centralize right here, and then paste, 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 paste until I fill it out completely. Boom. Now they look ugly, right? Now we do is select here, and I break this, and it's gonna change color, the top side. Now we have the batteries all in positive. I don't care. Select this again. I like the batteries in green. Wait, wait, wait. Select too much apparently. Let me make sure I don't select the top side. I want. You know what? The easiest way. Let's disappear this temporarily to make sure I don't select the wrong thing. Make my batteries or green or blue, maybe green. Yeah, Samsung's all right. Put everything back. Nice. Now I need to disappear my batteries. Let's disappear the batteries. Why I select the wrong thing? Okay. Disappear the batteries. These ones too. Because I need to join everything again. And I have a messed up here. If you notice here, I guess I make a mistake here somewhere when I was duplicating the batteries, but I nothing that we cannot fix here. Just like that. There's another one here. All right. Let me join all this now. Join. Boom. You're looking, guys, right? Let me. I'm reading the comments now. There we go. Let me go back to the design. We're almost there. I know this part is body, man, but that's the design. I moved this. I should not move this. I put it back. The reason why I should not move that is because I have the batteries there. I'm just waiting until this join. Tinkercad, come on. Let me put the batteries back. And now, because I want to see how it's going to look like the top, to see if that really fits, what I did is correct. Actually, we have a mess here. See, that was when I joined it. I messed up something here. Yep, I messed up something here. Probably the batteries is what is messed up. Nope. I will have to go back, 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 back. I messed up the design. That's what I messed up. Those batteries are not aligned. You know what? I'm gonna start over. I don't know if it's the batteries or what it is. It was when I joined something there that I messed up. But anyway, what I was going to show is how now it's like I need to pull the batteries just a little bit up, right? Just a little bit. Let's see if that works. I don't know why the system is super slow. See, like this, and then push. See, it's selecting the whole thing. It should not be selecting the whole thing. Let me put it back in place. It should be selecting only the batteries. See, it's not selecting the whole thing. Let's see. Probably there. I want only the batteries. Nope, it's not working. Put it back. Let me disappear this. I want only the batteries. There. Put this back. And probably it's not, it's too far away. Let me see. See, what I do is put it, see, it's too far away. I need to fix something here. But anyway, how I do the test, I mean, if they fit or not, first of all, I need to put the batteries all, I mean, match up correctly, which is going to be something like, let's see if I can do it like this. There. And then I duplicate this, um, put it upside down, and now I can pull that up. Let me see where is what I'm looking for the bottom. Where is one of the batteries covering what I'm looking for? Something is messed up here. That should not be like this. All right, let's go back with the same love. I'm going back because I want to fix this. The nice part in Thinkercad is that I can go back like just like this, go back, 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 back. Man, I hate doing this like this, but it is what it is. See? Let me see where I messed up. I messed up somewhere. Let's disappear that battery when life was beautiful. There. I guess the design until there is okay. Let me just fix this to make sure everything is okay. Break it and join it back. Come on, be nice. If you learn a parametric CAD program, any change will be like simple change. Man, I know. I even use. I have where is Fusion 360. See, I have Fusion 360. I have another one that is really good, and that is Sketch. I believe it's Sketchers. I guess this one is really good as well. No, it's not Sketcher. It sounds like this the name. You're not looking the screen. I forget that I have to enable that. So sorry for that. Let me just finish this part. Let me just get out of here and go back. It's to fix the model. There is. You know what? Let me share the full screen so you guys can see what I'm doing. Let me share the full screen. Stop sharing. Now I'm gonna share the entire screen. Share. So now you can see what I'm doing, right? Okay. Now let me change that color to this color. Now we can export this as an STL file. That's my and that's gonna be test top just as now I can go in my 3D printer. See, that's the Fusion 360. Let me close that. Sorry for the mess here. So I can go in Orca. Orca is for the 3D printer. Let me read what you guys are saying. Sorry for this mess. I know it's a headache. The pack configuration, Kevin, is 26 as 12p. 26L as 26 12p. All right, that's my okay. That's the Creality. Let me change that to. I'm gonna use probably the Ender. No, the Ender. The oh my God, where is my? Do I am in the? Ah, I know what it is. Sorry, sorry. I'm in the wrong software. I should use this one, which is Orca. Basically, it's Orca, but this one is for the Cobra, my Cobra printer. See, the Cobra is way bigger. So, and I'm using a new nozzle. Let me create a new profile because because I just changed the nozzle, but let me see something. Yeah, I need to create the Cobra Max. Now, instead to that nozzle, I need to put it with this nozzle. Oh, you know what? I don't have that option here for this point 0.6. Really? For that nozzle. That should be an update for this software. Let me see if I can get an update. Oop, I don't. I was not counting with that. Help. Uh, check for updates. No new version now? Really? Hmm. I need to download that. I just put a point 0.6 nozzle and it's not recognizing. So that's a boo boo. So I cannot do it now. I have to download that or use another printer, which is busy at the moment. Let me see what it's doing. My other printer is finishing what 68%. See, that's my other printer right now currently. That's the Ender 5 Max. Look at what I'm doing. Basically, I'm printing in here the basis for. Let me let me stop sharing here because it's a mess. There we go. Let me show you what I'm printing. There is this. You see this? Is this part that I have to send that to a friend from that battery? That's the battery from battery hookup uh, that I built. Basically, this is connected right now. Is 12 volt. It's horrible. I need to fix this. That's pretty bad. So what I'm gonna do is probably I'm gonna make a hole here to take out these cables and fix this design. To make it nicely. So right now this is copper nickel sandwich. What I have here, but I have the screws already in. So that's what I'm printing there. Um, yeah. Now I'm gonna be I need to fix the nozzle part on the software, and then I'm gonna be tonight starting cutting copper, a bunch of copper. Not this one. It's 0.2. I have to build the. Let me show you here. I'm gonna be printing. I'm cutting um, this one. Actually, you can see it here. These bus bars. I need to cut these bus bars. I need to cut 17 of them. This is gonna be a long time. Probably not gonna finish today. I need to print few of the corners, which is these ones. No, that one. This one. That's the one that I used to join. I need join how many times? Once, two of those because it's 3 stories. It's gonna be just like this one, but with a new tray. This kind. So let me show you how it's gonna look. This one. Let me duplicate this. Pull it. Change. Oops. Man, this is a mess. I don't know what's going on. Honestly, I don't know what's going on. This is a mess. I don't know why it's doing that. Look at that. That's a mess, man. Look at that. It's even man, this software is glitching. It's glitching very bad. Let me get off here. I guess it's too much for the memory. And my computer have a really good memory. It's not the computer, it's the browser. I guess it's their software. I have 128 gigabytes, so and the video card is a beast. What I have here, so it's not the computer. I'm very sure. Let me try this again. Let me make sure we have the correct one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14, 15, 16, 19. Well, wait. I guess there is a problem here. If you notice, it's not that one, it's this one. Now I know. Yeah, this is the one that I'm working with. I don't know why that one was even there. There we go. Let me duplicate this, put it up. Let me make sure this one is not duplicated. Right, no, it's not. Now swap this. There we go. See, it's glitching. And now I'm gonna put it right here and boom, we got it. That's gonna how it's gonna look like when it's closed. All right, and now we go to. Let me see your comments, guys. No issues. Still under warranty. Kevin, I want it to be a MOSFET or create an open circuit. What's happened with your glitter? It's sticking one of the electrodes or something like that. I'm trying to catch with the conversation. Sorry, man. Um, like order EV50PL for that. Uh huh. I can use a 0.15 copper. Yeah, man. If you are gonna use, how much current are you gonna be putting from that pack? Let me. I'm answering this. How much you're gonna be putting there? Because I mean, point. Let me see. I tried with point 3 all the way to point 3 and blows a hole on everything. Really, uh, if you leave soft, I mean the connection, you need to make it tight. It make a hole, man. You need to make it really tight, and point three, depending even the for the egg 11 is tough. It's tough. Yeah, man. For the egg 11 is tough. Are you using what you're using? A copper nickel sandwich? Yeah. Well, s- you need to check few things. I mean, the reasons why you can blow holes. One is because it can be soft. Maybe you think that you are putting tight, and it's in the other side. Man, it's in the side that goes to the connection. Okay. What cells are you using? The JP40? Yeah, yeah, but check it out because the glitter egg 11 have a problem. In the other side, so where it's connected to the machine, if it's a little bit soft, like I mean, because when the cable jumps, they get a little bit disconnected if you are not using the screws. So that side can lead to make a hole in the battery, believe me or not. So you need to check that. The other thing that you need to check in the glitter is that the sockets are tight. I tried sandwich and pure copper. Yeah, but for point three, you need to use flux. You need to use flux. I mean, even me, I don't know if you see my last build, but yes, with JP40, I was making JP40 is a soft can. Uh, I had to modify the boss bar. Let me see if I have one boss bar to show you something. Let me see. Oh, I may have one here, maybe not. All right, that's not the one that I was looking for, but it have the same. This is a damaged boss bar. This is point three, and I was using the glitter. But do you see what I have to do in the boss bar with the laser? I have to take out about 0.05. So I make it pretty much this 0.25, right? In just in that area, to help the glitter to be able to weld without flux. Really, with flux still doesn't do it. I'm talking very high settings. You will need to use with the glitter egg 11 probably. With the JP40 I use like 65 because I don't want to go too high with JP40s. Otherwise, you can punch a hole, man, with the JP40s. I have a video that I was punching a hole with a JP40 like that. So I mean, it's tough. 12.3 with JP40s. It's tough. So I recommend the people instead to going point three, go with point two and stacks. You can stack always. One boss bar on top of the other one. So you start copper, nickel, and then copper, nickel again. So and even you can make it even a stronger boss bar. I mean, in that way, stacking. And because you have the first layer in copper, you're gonna pass that good conductivity to the full pack, even when you have nickel, copper, nickel. So you're still good, believe me. Uh, it's pretty done. Drivers only. Let me see. I'm reading what you guys are writing. Okay. Yeah, man, and 10% or 20% is blowing holes. The glitter. Man, you must to have a bad MOSFET if it's doing that continuously. I mean, that's the only way to explain that. If it's blowing holes like that, if you have a tight connection and all that, it's gone. Those MOSFET are not controlling the current pass. Yeah, yeah, it must to be like that. And you're not using automatic mode, right? You are using the pedal. You're using the pedal. I guess we have a delay. Are you using the pedal? Yes. Okay. Most likely you have a bad MOSFET. I mean that I seen stuff like that happen. Yeah, and end up being a bad MOSFET. Oh wait, but no, no, but the keycap that's for the key well. He have a glitter. Dímelo, Ori. Christopher, todo bien. Oye, he's from RD, from Republican. I mean, well, he's Italian, right? Christopher, you are Italian, but you are from Dominican Republic, right? Yeah, man. Yeah, even with the pedal, if that's the case, man, if you have less than a year, no call, because send an email to Glitter and good luck because they take time. Let me do you a favor, make a video, very clear video, take pictures and send everything in one shot. Yeah, and send everything because the first thing they're gonna say is I need to see a video. That's the first thing that the guys from Glitter are gonna say. They want to see a video, and you need to convince them. I mean, if you're under the warranty, because they really are trying the warranty a lot, and I hate that when they do that. Um, I'm checking something quickly here. Sorry, guys. Okay, I don't know if you can see the screens. Checking something quickly here. Give me 1 second. I want to make sure that if I have a client waiting for something, I'm not making them wait. Uh, what is this? Account number. Okay. Sorry about that. I'm checking something quickly here. Okay. Okay. I need to check something here. And what else? That's good. Okay. Was checking the a few emails. I have to fix something there. Anyway. Hey, how you doing, Samir? How many people we have here tonight? Let's see. How many people? Let me see in the chat. I can see the chat overlay. Let's see. I'm using a software. I'm using a software that I can invite six guests. I invite up to six there. Upgrade for more. Okay. If someone wanna join talking, you can join by clicking this uh, that link, and you will join like a host, I mean, like a conversation with me, so we can talk. With you can use your microphone if anybody want to join. I mean, even the camera if you want. So you guys can join. So let's see how many people we have here. Let's see. That's the so this software is how it's called Restream. Talk about a with welder performance versus glitter. That's a good topic. I mean, I try not to push too much because I know many people have glitters. I mean, honestly, and that's a topic that is, well, I repeat this many times. Uh, Glitter is crying too much their warranties, honestly, and they know they have a problems, especially with the 801H. They are having problems that the board sometimes stop working charging the for the copper nickel sandwich. Let me answer your questions here. So if make a difference, it depends the drone that you have. It depends the drone that you have, because I mean, the question is how much current do your motors, your no the motors the yeah, I mean the motors they pull. I mean, if you are pulling, for example, more than 30 amps, you should start using copper. If you are pulling 60 amps, then you should start using a thicker copper, you know. And if you are pulling way more, I wish they have the new welders before they push the glitter. Man, you know that I bought glitters. I have all the glitter. I still have them. The problem is that over the last 3 years, Nix had joined it, add to the stream. Let me add you, buddy. So now you can join us and you can talk. Let me make
Okay.
this a multi-stream. So that's unique. So um, the thing is, in the last three
Um,
years, I've been losing PCBs. I mean, hey, I use the welders very strongly. I mean, very often, and I weld heavy
yeah.
copper. So, how you doing, Nick? How are you, man?
Hello. I'm good.
Everything good?
Yep.
So let me see
So,
exactly. You was making a question here, Nick.
uh, I forget. I don't know.
All
I'm
right.
just here because I don't like chatting.
Yeah, I'm answering to this to Samir. The question for the actually two question for the copper. Okay, for the copper, it depends how much current do you need. Then you should start using copper. Okay. And the other one, compare the. Let me see. Someone. Let me see if it was one of you guys.
I feel
Who
like even if you're not pulling a ton of power, it's if you have the ability to do copper, if you do like 0.1 millimeter copper or something, it's
exactly?
just might
Um,
as well.
and it's better for the copper. Not only that, it gives you more conductivity, so you can when you use copper, you remove the heat faster from the
Yeah.
battery. So
And
because the
also it's like cheaper too.
yeah,
Nickel's so expensive.
copper is cheaper. Copper is cheaper than nickel. Copper is cheaper. So I mean, there's one downside in copper that many people, well, you need to be aware. Copper is corrosive. I mean, but so do the nickel steel. I mean, it's even worse. Nickel steel is even worse. But if you are not using the pack in a humid environment, or I mean, where it should not be wet. You know, I mean, first of all, it should not be wet. You're fine. I mean, I keep an eye in my packs, and I use copper, and I open mines. I mean, and they're fine. I mean, honestly. Another choice, if you want to make sure and you have the time and the patience, your copper, once you have the copper ready to go, before welding, you can electro plate it. You know what is that, right?
Mhm.
So
Yeah, you can buy nickel plated copper as well,
you
just
can do that,
directly.
but when you make a boss bar, a big one,
Oh
good luck.
yeah.
Good luck with that. Good luck with that. Buying some, I never seen one. I never seen it in
I've
rolls.
seen there's some companies on Alibaba that will make stuff like that custom for you, but you have to be buying like at least a kilogram of it. So
Exactly. I mean, of course. I mean, I can do it for you. If someone pay me, I can do the full roll and send that to you. I mean, but are you gonna pay what that costs? I mean, I can. I mean, you can do it yourself. You can do it yourself. Let me share the screen with to show you something.
um, something
Uh,
I was been looking into was using wax, like thermally conductive waxes and stuff. But also, if you just take your battery and you just fill up the whole case in wax, that's pretty waterproof.
yeah, I
You
mean,
know.
there's few. Hey, there's few choices. There are few choices. Let me show you something in Amazon here. My
Mm,
Amazon here. You can
yeah.
search for how it's called, nickel powder for electro. Just put electro. Let me see. Is that's what you need? See,
Yeah,
nickel
yeah,
plating solution. That's the name. That's a
yeah.
nickel
Let me
plating
just make it.
solution. You get that nickel plating solution. Actually, you can prepare the solution if you get it in powder. This one is already built. This one is already built. See, you can take
Yeah,
something
it's
like that,
probably
and
yeah, it's
then
definitely probably cheaper to make it yourself because that seems pretty expensive.
it's
But
well,
yeah,
this one is very expensive. Yeah, but you can put it. Let's see.
because depending on the process you use to make it, or if you're just directly like dissolving it, or you could use
You
just
can get it in
electric
powder.
nickel
See,
electrodes. You can get you don't even need it to be like the most pure nickel or anything.
yeah, yeah, you can get it.
Because
See, like a metal in powder. They
yeah, you
make
know,
it. Let me see. They sell
depending on what the impurities are, they may not, dissolve
exactly.
or anything. So
It's
you might
cheaper. I
be
mean,
able to buy some cheap like nickel bricks off of like AliExpress and just dissolve it or whatever.
yeah. Let me see. If I put just nickel plated solution, probably I'm gonna have more results. See, that's a solution. That's already built, made. I mean, but you can buy the powder. Let me
Mhm.
see. I guess that's the one that I got. This one. But you
Yeah.
can buy the powder that is even cheaper. And then the powder, see, well, let me see. This is already made. The powder is cheaper, and then for the powder, there is a process to make the. I mean, you convert the water in like in a green water, just like that. See, so you have to use vinegar. You have to use hot water. There is a process. If you Google it, you can see the process to prepare. It takes like an hour to prepare that. And the thing
Yeah.
is, not all the time. I mean, you get the same consistency. I'm trying to find the
Hmm.
powder. Usually,
Oh yeah, definitely. Like potentially one way to be consistent about it is there's various ways to make you're making different salts or whatever, and you can use
exactly.
if
And
you know the purity, you know how much of it's nickel, you can make sure you get the right amount of nickel into the same thing. But yeah, the more steps you add to do yourself, the more variability is going to be.
let me show you the one that I got. This is the
Have you
one that
ever? Oh yeah.
see.
Oh yeah, yeah,
It's
yeah,
the same one that you're seeing in Amazon. So
yeah.
um, again, I mean, I use that only for very special
Hmm.
cases. Like I know the battery is gonna be used and it's gonna be exposed to humidity.
Hmm.
Yes, I mean that's hey, that's why I like to. I mean, buy it already made. Mine is already made. I mean, I have the liquid here, so I don't have to prepare the solution and all that. And I did it once in the solution. I mean, not once, a few times. And man, is there we go. Look at this, guys. You cannot electroplate with nickel powder. You need a nickel salt and electrolyte with the powder source. Yeah, exactly. That's why. I mean, that way it require more when you use the powder. I mean, it require much. I guess even. I mean, you need to use vinegar. There's a few things that you need to do, unless that you use the solution that is the liquid already made, and that one is just very straightforward.
Yeah,
It's,
and I
it's,
mean
it's put
usually
in
those.
a pan, and you apply. I get 16 volts. I mean, and it's about 1 amp, 2 amps, almost. It's not even 2 amps. You leave it for a
Yeah,
little while, and you.
dissolving the powder is probably more than it's worth, but if you're doing electrolysis and you just have like some bars of cheap nickel or
So
something, you could
much.
dissolve that. It would take a while, but it wouldn't be too
Do you
difficult
say even
usually.
using the solution is better if we add salt to the solution?
Well, that's those solutions are nickel salts. Like that solution's probably got some amount of like nickel sulfate or chlorate or
Yeah,
some mix
because
of them that they found to
I mean,
work well.
I use it without salt. I mean, it
Hmm.
takes time. You need to move it a lot. I mean, you need to move it a
Yeah.
lot, and
So
it takes it at
potentially
the end. But if
there's a balance.
much says that apparently if we add salt, maybe take it better. Or
No, no, just
much
there's
are you talking about if you make it DIY the solution?
Yeah, for the DIYs, it would be difficult to dissolve the nickel from the metallic
Yeah,
state
yeah,
in a powder form. If you're going to dissolve it, it's almost certainly going to be easier to do it with electrolysis, and then you're going to need like a bar form anyway because you want it to be conductive.
yeah,
Yeah, and I've considered that a little bit because that would be kind of a fun project. But yeah, I mean, have you looked into like conformal coating stuff or anything in terms of just like coating the battery terminals after, not worrying about all the plating? Because honestly, even with like a plating solution, seems like a lot of hassle.
yeah, yeah, yeah. I mean, that's it's not that's I mean, it takes so much that honestly, I don't even do that unless you really
Yeah,
need to. I mean, and there are a few things. I mean, there is like how it's called. It's like a coating protector that you can spray to the
hmm,
copper to do the same thing, like a coating, to protect the copper
yeah,
from corrosion. That you can do that after you build the battery. You can spray that, and that will protect as well.
hmm,
I mean, but honestly, I mean, unless that you are gonna be using the battery in outdoors, like you are gonna be in the mud and stuff like that. I don't use that. I don't have problem with that. So to be
yeah.
honest,
I think just like a proper PVC wrap or polyolefin
yeah, yeah. I mean,
shrink wrap or
if
something
you
probably
seal
good.
well the battery, I mean, I never had problem with that. I mean, to be honest with you.
Yeah.
But again, if you really don't need copper, do it with pure nickel then. I mean, if you are
Hmm.
gonna, it's like I seen people making batteries sometime for pool 3 amps, 10 amps. I mean, I do it with copper because it's cheaper. You know, I do it with copper because it's cheaper.
Looks nice and shiny and coppery.
No,
Yeah. Or
we are talking about the copper. Much that the copper alone, I mean itself, it could be corrosive. Well, it's not corrosive itself.
I
It's
mean,
like made patina. The like
yeah,
the
La Patina. I don't think I'm too worried about the copper like oxides and stuff forming because it passivates somewhat, but it's gonna be very slow, and then that probably won't be like a problem too quickly. But
yeah.
yeah, well, so that's the thing with a conformal coating. Like it's an extra step, and so that's maybe not always like worth it if it doesn't necessarily do anything. But the thing is also if you do the conformal coating and you don't do it properly, that'll mean it's
It could
still
be
rusting in
worse.
some spot. It's just as bad,
It
or
could be
maybe it could be worse
worse.
depending on
Correct.
the electric effects. Like if you have like a lot of the rusting in a battery could be driven by the fact that you have voltage there, and so if you have a smaller area, then it might just rust that really fast, and
Yeah,
that might be
yeah.
worse.
It could be
So
worse.
there is some
Correct.
consideration.
Yeah, but much. I mean,
Yeah.
we are talking if we what plate before welding, plate the
Mhm.
copper. I mean that's what we are talking to
And so the
to
thing is with the galvanic corrosion, like yeah, it's an issue with the plated steels and stuff, but when you have like battery cells where you've got the battery cell is probably a steel can that's nickel plated, and that you've got the copper on it, then there is some potential for some galvanic corrosion there. But you know, hopefully there's no corrosion on like ideally if you've done your solder joints right, you've done your weld joints right, everything that won't even affect it too much. And if you have enough corrosion to like actually eat its way through the whole layer of copper, you may have other problems. Your
it's
cells
a
might
bigger
have had
problem
problems
exactly.
first.
You have a bigger problem than that.
Yeah. So it's
Yeah,
like it would be nice to make sure that that wouldn't ever happen, but I think it's not worth doing extra things just for that, like a conformal coating. Unless you were doing something really fancy, like you were wanting to do some water cooling setup, then yeah, conformal coat everything to be sure.
yeah, man. I'm talking about cooling. If you are for cooling, do you seen the earlier what I was showing? I mean the new
Mhm.
material for the
Yep.
3D printer.
Yeah, no, I've looked at some of the stuff and none of it seemed very useful because it's kind of low thermal conductivity for like a thermal compound. Um, yeah.
Correct.
Yeah, oh, so the welding,
That'll go away when you weld. I mean that's anyway in the welding you are not protecting anything. I mean, but
yeah.
and the rest. Honestly, who cares?
That's
I don't care about the patina. I don't care. The thing is, the patina can lead in bad corrosion, but buddy, it needs about like 2 years, three. I mean, like 3 or 4 years. I'm sorry.
yeah.
If my battery give me 3 years of service, I'm happy with that. Honestly.
And I mean, I'm willing to go do a little extra stuff or spend a little extra time to make sure that everything's all nice and pristine in my packs. So like, I might try some of that stuff and just see, see if it's something that isn't too much extra work and if it's, something I can just
Yeah.
do.
I mean, the best.
But it's really not worth it.
Yeah,
So
yeah. What she says is just keep the water
yeah.
out. I do what I do. Let me show you something. For example, um, I have a bag here that I built. Right. So this is for sale. Maybe it looks
Mm.
ugly. Do you see that white? I mean,
Some silicone.
it's because I use the silicone, the special silicone,
Yeah, yeah.
that it really works. I mean, that's the Chinese
Hmm.
silicone, but that really works. I mean, keeping the pack sealed. And I use,
Yeah.
if you notice, this is not PVC.
Yeah, it's a
This
polyolefin
one,
kind of
this
stuff.
one, this one is a very specific material, which is like rubber. Man,
Hmm.
I'm gonna share
Yeah,
the
that's what
link.
I use.
Man, it's
Is
expensive as hell because it's like
oh,
it's just like the double wall
mhm.
heat shrink.
Yeah.
Very, very
Where do you buy that stuff from? Because I've had a lot of difficulty buying it.
AliExpress, man. But it's this
Because
the
like even on AliExpress, it's so difficult to find it in
it's
large enough
difficult.
sizes for
Yeah,
packs.
yeah. Let me
And
show
then
you.
it's like $30 for a meter. But
Exactly. This thing costs
yeah,
$33. This,
yeah. Yeah. I have some of that for some
and even
packs and
I
it's
have
like it's
big.
very nice. It's
Yeah, it's
when it
very
and when it
nice.
fully shrinks, that stuff it forms like a protective hard layer almost. It's good stuff. It's like and it glues in, it seals it. It's
Let me
great. It's
show
just
you
so
one.
hard to find even.
This one is even bigger.
Mm.
And I
Yeah.
have even that in 450 millimeters. It's
Oh
huge,
yeah.
but
Some
it's
of the stuff I have is so it's like so thick that it's actually stiff. Like that's flexible like rubber. Like this stuff is already this like stiff sheet, and then you heat shrink it and it gets like twice as thick. It's very. I imagine
yeah,
that that's a lot
that
of
material.
protection.
I love that material because it's really so thick that really
Hmm.
protect the pack outside. I mean, if you
Yeah, I
don't
had
use
to
a
buy a whole
hard
nother
shell,
heat gun.
if you don't use a hard shell, I mean, it really protect the pack.
Hmm.
Much.
Yep.
Now that you are here, let me show you something. Much. There is a material. Let me share that with Much. Maybe he don't to see what he think about
Yeah,
this.
and
Uh,
also with the packs that I use, like yeah, I want to keep the outer case should be sealed and then a wrap that's sealed. But
Much.
a lot of the time I 3D print the cases, and so that introduces the problem of the fact that well 3D prints are really hard to waterproof, and so I'm always so like if I'm selling something that's got a 3D printed case and it's that is not waterproof, and so then it's only one layer of protection for the waterproof, the
Yeah,
shrink
correct.
wrap, and so that makes me want to have another layer of protection because like okay it's probably like very little water will get in and where I live it's very dry so I don't expect it to be a problem here, but if I'm selling it to somebody who lives near the ocean then yeah maybe a little bit of water vapor and salty water vapor will make it through the case just because it is a bit porous, and
Yep.
then hopefully I've done the wrap right and it's all sealed up.
Yeah, I'm in the wrong. Let me see if I can. It's because when I open that, let me share the correct screen. Replace with the other one. This one. Much. Check it out. This is a filament for the 3D printer that is thermally conductive. They use this filament for heat sinks. That efficient is supposed to be. See, to make heat sink.
Yeah.
So the idea is make fins.
So I'm
Uh,
actually really curious about that because that's several times less thermally conductive than even like stainless steel. So
Correct. No, but think
that's
about
not good.
this. My
Make a very
idea
good.
is my idea is imagining if you can make the case, the full case, for the battery.
That's what I'm saying, Mooch. Like
Make out of
I've been thinking
that,
about using like wax,
and
just
then
soaking the whole thing.
you make as well the battery tray made out of that,
Oh yeah, I see.
and then you can really extract the heat very easy. I mean, from the pack. I don't
Yeah,
know, honestly. Keep the water out, then no. Yeah. So yeah, I mean, that was something very interesting. Honestly, I'm gonna buy it. I'm gonna buy
mhm,
that that thermal conductive. To do few. Maybe I can start, for example, making heat
mhm.
sink for MOSFETs.
Oh yeah, that'd be
Then,
good. I think.
and then I can see in the thermal camera technically to see how that behave. Because look at this. I mean, if it's true, look at what they are doing. This is like a. You see the two water pipes, 3D printed. I mean, it's supposed to work. I mean, what for the price? I mean, I will try this filament because if this really works, uh, that's a game changer. For building packs. I mean, it should be pretty cool.
Yeah, because I've been looking at some papers and reading on thermally conductive waxes because theoretically you can make a fairly thermally conductive wax just from just some paraffin wax, dirt cheap, and zinc oxide, also dirt cheap, just available commercially for you can get like ideally you want to use like nanoparticles, but you can get it commercially for like sunscreen stuff, also very cheap. And so there's some papers where they found they put a few percent by weight zinc oxide into paraffin wax, and then it was reaching like a thermal conductivity of 1 watt meter Kelvin. So that's significantly less than that plastic, right? But then also like a whole battery pack, you could just fill it with a bunch of wax, and it would cost you like $5 to do that. And so
Yeah,
I'm considering that because like that's a very good thermal conductivity thing. It's also acting as a potting material, so that adds some structural capacity or whatever. And plus, waxes are pretty high specific heat, so that adds some more thermal mass to absorb like peak power bursts. Like if you're using high power cells like tablet cells, maybe that's not useful for being able to absorb the heat from putting like at like 100 amps briefly. I'm thinking
yeah.
about that, but I've
Now
made
the
up a
other
couple
thing that I
bits.
need to
But
check it's to make sure that material is not electrical conductive. It should
mhm.
not, but
Yeah, so that's why you use zinc oxide because zinc oxide by itself is not very thermally conductive. A lot of the papers also look at stuff like carbon nanotubes and graphene. And so then obviously that's not very practical, but that also makes it more conductive. But the zinc
yeah,
oxide can form the network that allows it to be thermally conductive, but it itself is not electrically conductive. So you can put a fairly high percent into it, and it's still a good insulator.
yeah. So there's a question here. He have if it's possible to wire, solder a wire to a cell without damaging. Not, I mean, the best practice is not to do that. Uh, yeah, soldering is a no at all on the cells. I mean, because it transferred too much heat, and that can damage the chemistry inside the cell. I mean,
I've wondered if with tablet cells using the like soldering it damages it less because it's spreading the heat better through the larger connection. But
it's
I'm
still
still good at spot
it's
weld.
still I guess it's still the same electrolyte, right? Much, and it can
Yeah,
crystallize the electrolyte. That's the problem.
yeah. So
It's,
that's another thing. The basically the pack I'm already wanting it to be waterproofed, and so then since I 3D print cell spacers and stuff, I've got some designs that are basically themselves waterproof. But I wouldn't necessarily trust it with water as much, and then I would wrap that in heat shrink, and so then it would have the wax. And ideally, the wax wouldn't melt too often. I think melting it and utilizing the PCM nature of it would be useful for high energy, like high power packs. But it's very hard to keep zinc oxide suspended over multiple melt cycles. I've had a lot of difficulty with that as well. Um, yeah, good for pulsed. So that's kind of what I think would be good for like really dense small packs. You can add a good amount of thermal mass to it just with a couple 100 grams of wax, and it's like pretty easy to make. I've been trying like some surface treatments stuff onto the particles to get it to actually stay suspended better. The stuff's cheap, but it's a little bit of a pain to make.
Can you share
I
the
don't know.
wax that you use for that? I never tried to do that. To be honest with you, that's new for me.
That's why I don't know if Battery Mooch has been trying specific like commercial products. I haven't looked a ton at them because they all because I've just been seeing about what I could actually make. I
Mm,
just so far for my testing, and I have more testing than I actually do at different, like actually tracking the temperature difference stuff. I've just been using just some straight up normal paraffin wax. I think ideally with the you want a wax that melts around 70 degrees Celsius, so it prevents it from getting to 80 Celsius. So you can use like a refined paraffin wax. You can just buy that pretty cheaply, and that will have a melting point around 70 degrees Celsius. And then you can buy zinc oxide nanoparticles, which are the ideal thing in terms of thermal conductivity, or just zinc oxide like microparticles and just put more of it in, and it's cheaper. But then the real problem is that to actually suspend it, you need to have the wax melted, and you need to use ultrasound to suspend it, and you need to do that a lot. And then it only stays suspended for a few hours, really. So without further treatments and stuff, even with like dispersants added, and I've tried a few. So the using it as a PCM where you can thermally cycle it and melt it and then use that to store energy is great, but potentially difficult. Um, I've been trying to figure out ways to make that cheaply work, but the using it just as a thermal compound where you pour it in as this thin wax, so you don't need to worry about putting it together when you're building it, and then not ever melting it, so you don't have to worry about it settling out. That's pretty easy to do and cheap, but I don't know.
huh. I need to play with that. To be honest with you, I never play with that.
And
Um,
yeah, there's some good papers on this kind of PCM stuff, but a lot of it seems very preliminary, honestly. So I've been wanting to do more. Um,
cool. That's cool, man. Well, man, I'm gonna be now. Yeah, I have to, man. I have to call those boss word. That's not funny. It's, I mean, if you think the 3D, well, the 3D, design is, it could be. I like it. I like it, the 3D
mhm,
design. I mean, the thing is, I maximize what I can do in Thinkercad, and I start using again. I mean, Fusion 360.
mhm.
There's another one that I'm using that I really like it. Let me see if I can find it. Then I forget the name. Um, you maybe guys, you used this before. Let me find the name. Come on. I'm checking my browser. Okay,
Yeah.
to give you the name. Sharp 3D. Let me share this.
Mm.
I don't know if you guys ever seen this one.
Is that kind of like fusion in how it works, or
Yeah, this one is the software. It's really really
mm.
good. I
Oh,
tried
Shaper
it.
3D?
I mean, I tried it already, and I really like it.
Hmm. Oh, that's interesting.
Look at that.
Yeah.
So you have a bunch of functions, and many people say is based in the reviews that is even better than Fusion 360.
Hmm.
And they have a free version, and I was playing with the free version. See, it does, you can put material same as
Oh, the
Fusion.
materials is nice.
See, but
Yeah.
it's more, honestly, it's more user friendly
Hmm.
than Fusion. And I start making battery trays and stuff like that in that software. Honestly, I really like it. I really like it too.
Yeah,
So
I've been using Onshape just because that's what it was able to run on my like weak laptop,
yeah.
and so I've got my stuff set up for most like generic kind of batteries. I have pretty parameterized like files, so I can just say, yeah, I'd like it to be this many rows and columns, and it kind of handles most of that. So that's nice in terms
Yeah,
of
I
saving
want to
time.
share another software that someone, let me see, someone was pasting, and I know a guy that was making something similar. Let me share something that you may like this.
Hmm.
Let me open here this. Let me share this. You guys tell me what do you think about this. This one is a utility. Look at this to create like, let's see. Oop, to the other side. Number. Let me change the number. Come on. Connection is this one is. There is few tools here. Okay, here. That's the tool. Number one, number two, for example. Look at what I'm gonna do with this. No, not that one. Here, and then I know I can tree. Right. Okay. See, I'm making like the connection for the batteries between four of them. Actually, this is wrong. I need to eliminate this one. Um, and then anyway, the nice part of this is that allow you. Look at this. You can create the bus bars based on the connections. You can
Ooh, yeah,
change
yeah.
cell dimensions. For example,
I saw
21.
this one.
Um, is still in like prototype the software where you can change it even in the boss bar. If you have the boss bar, look at this, you can change the type of, so if you want to make it solid, look at this, to cut it. So I can make it,
Yeah,
for example, with the laser and cut that. And the nice part is that you can keep going making different frames and batteries, and then you can tell, let's see, where is the frame, battery capacity, load, measurement, and here you
yeah.
can tell I want to make, for example, whatever you want to do, and it make you different options for the bus
Ooh,
bars.
hmm,
See,
that
uh,
is nice.
this is it's gonna be a very cool software. I mean, if we elaborate this, see, I mean, it's, well, this is wrong, but if we make it longer, for example, and then you change the configurations here, see, it can change you. I mean, if you want to make
Yeah.
it different
Hmm.
uh, configurations, see, I mean,
Interesting
in
to
here, the
this.
good part is tell you how, see the right side, how consistent is that connection, and how many amps you can.
I think that that particular one's a little bit wonky.
7 and 8. It's a 7 and 8. Yeah, yeah, that's really bad. That's really bad. I mean, that's a bad one.
Something's up with that.
Yeah, yeah. Remember, this is an algorithm,
Yep.
and this is just
Yeah, that's pretty cool. I was doing a little bit of beta testing on that, and then I upset
but
the
I
guy who made it too by
oh,
asking him
look at the
questions.
number one. That's so awful. But you know what I mean? The thing is, when you do it manually, like let me see. When you do it manually, for example, you wanna do it manually. This is what I want to
Uh-huh.
show.
Yeah.
Uh, if we go, for example, and we start from number one, right, and then we make one, uh, for example, number two, and then number three. Oops, number three, number four.
And this is definitely way smoother, like way less complicated than doing it in some CAD program. But with the way like parametric CAD works, it's like not really worth. It's difficult to import files like this into it because the whole point is that it's all parametric and you can all adjust it, but then it's hard to parameterize an imported file. So like it's unfortunately a little awkward to use something like this with when I'm designing the rest of the pack in parametric CAD.
Correct. See how awful is that part? what I so.
Oh,
But the thing is, actually, you can use Control Z. Look at this, Control Z to put it back in the way that I put it originally. So
mhm.
here's the thing: do you see this part? And then it tells you how consistent is the connection. Let me see. What is the offer part? 5 and 6. 5 and 6. It says bad. I mean, let's see. Well, it's not the best, but I mean, it could be. Um, I don't know. You know the point that I what I mean.
Yeah.
Um, oops, is that one is? No, this is awful. It should be here for the last connection. Oops.
I mean,
There.
sometimes when I'm doing like triangular packs, the shape of the bus bars get pretty egregious just
Yeah,
because it's so
yeah.
hard to fit.
The thing, let me see. This is messed up. I mean, let me see. 5 and 6. I you know I see what it is. I make a big mistake. See, if 4, 5,
Mm.
6. This is should be 7. That's what it is. This one
Oh
should
yeah.
be. Let me see. 7. Come on. It's not selecting. I still learning this thing, man. Uh, is that what it is? Come on. I messed up here. Anyway, the thing is, when you make it, well done, symmetric, it work. Okay, I got it here. This is what I need. 7. This 8. This 9. This 10. There we go. Now look at that. 100%. See?
Mhm.
And we have that completely symmetric. The nice part is when you are designing the boss part, this software help you telling you if what you're doing. I mean, I really like it. I mean,
Yeah.
this is a simple one, very simple. See the boss bars, you can
It's a
make
nice piece
both
of
of them.
software.
See, that's all. This one and the other one. Or if you want to
Mhm.
make it, as I mentioned, I mean, you thinner. I mean, the what it was.
Like one of my designs for a
Here.
battery pack. It's not like a ton of high power, but like it's a triangular pack, and so one of the bus bars is basically just going through the connection that's like as thin as one cell. So it's got like a constriction for 25 millimeters wide, and it's like
Oh,
it's fine because I'm going to
that's
use
a
thick copper for it.
man.
But it's also like, man,
I wish this software it's complete because right now the sad part is that if I want to export right now,
Mhm.
the idea is that you can export this to I mean um to the Tinkercad, or you can export
Mhm.
this to any software. I mean the frame, the whole thing, and even have for the case. If you want to make
Yeah,
the case for it, I guess one of these one, let's see, quick center, X erase tools, toggle read. Let me see. No. One of them, it's see, this is connections. Share, I guess that it was. See, it's saying not connection to the server. I mean, I wish this is completed. To be honest with you, I mean, and I will buy this software because that make your life so easy. That I mean, I
yeah, save a
guess
lot of time.
these guys are still in work. When you go to the website itself, look at what it says. Coming soon. Do you see that part?
Yeah.
So it's not even finished yet, the software.
Yep.
So that would
I
be cool.
think something I might try and do is that in Onshape it has a custom scripting language, so you can code your own little like tools and stuff. And so I think a useful thing for me, whereas this would be awkward to incorporate into my workflow, like a this the way it lets you easily pick things and outline the bus bar and stuff would be a very useful feature as a little script in Onshape or something. So I haven't learned the scripting language, but I might do that because then that would save me a ton of time.
Yeah, yeah, man. I mean that really is gonna help. I mean that software. Okay, someone is asking for the P60B. That's the Molly cells. Uh, Actually, was the P60B or was the other one? Oh my god.
I saw Molicel announce the like M65A.
Yeah, no, actually, they announced another battery. Much, do you remember the name? That was
I think
the 60
Mooch
P63.
might have left already.
Oh, he left already. Yeah,
Yeah,
there's
he said
again
good night.
another battery that I
Hmm.
mean I'm in process of getting.
Hmm.
Let me see if I can find the contact. Give me 1 second because I sent that too much and I'm waiting to get a response. Give me 1 second. Let's see if I can get that information for you guys. Um, Sorry about that. I know you are not looking, but I mean, I will tell you now. It's because even I got a data sheet. I'm gonna show something in the screen, okay? That I shared that only for the subscribers, but I'm gonna share that with you guys. Let me see where it is. What screen is? Give me 1 second. Sorry about that. Let me open the file so I can share that. All right. Let me go back here. Check it out. This is not the final copy, okay? It's not a final copy from the P60B, but a Much found something very interesting here, and it that says, look at the discharging side, 1.8 volts, which is it must be a typo.
Damn.
It must be a
Yeah.
mistake, but at least we can see here. Look at that. It's gonna be 21.6 watts hour. Don't take this as a granted, okay? Because this is not it looked like a preliminary. Look at the version that this has. It's not even one. It's I guess it's 0 point. Where is the version here?
I
uh
think we could see cells like that soon. I don't know. We'll see how this one turns out. But
yeah, so here, look at the version 0 0.1. I mean, normally when they go to the version itself is number one,
mhm.
and this doesn't have a signature that usually the data sheet they are signed. It's possible that somebody recreate this. I mean, but the thing is, the numbers are close to what Molly sells in the beginning. They announced, so that's possibly what is gonna be the P60B, which is pretty cool. If you see the discharging rate, I mean, current 60 amps with a maximum of 100 in that milliamp 6,000. I mean, it's more the watts hour. The
Yeah,
minimum is
10
5850,
10C discharge high
but
density cells are
I mean that's
pretty
gonna be
nice.
great. I would love to see the lifespan test. The longevity in the cell.
Yeah.
That's gonna be very interesting. That cell. Benji, look at what he says. Man, I wish someone makes a cell, but do you see in the other part? I mean, because that right now, Bat Cell they have the 6300 milliamps, but it's at 2 amps discharging at 2 amps. They give you that, and then you put the cell discharging at 10 amps or something like that, and then it drop to I don't know to 5200. You lose so much and sagging
Oof.
and all that. I mean, it's terrible. So I wish they give you those six. See, I mean, 6 amps hour, giving you that high current, like JP40. They says we are gonna give you 4 amps hour, You discharge a JP40 at 40 amps hour and give you more than 4 amp hour, more than that at that discharging rate. That's insane. The
Maybe
other
Eve
cell
will come out with a 60 PL.
that does the same thing is the 50, the 40 PL. It does the
Mhm.
same. Give you more than what they claim in over 40 amps discharging. That's insane. I may have few graphics here. Let me show you something. Share something with you guys. Let's see. I'm gonna share some my full screen just to show you this part. Um, Entire screen. It's gonna look kind of awful, but I have a bunch of data here. See, from testing. See, back 45 days. My testing. See, with the equipment. But I made few interesting graphs. Like, let me see where I put it. I guess I put it in the last results here. Let me see if this one is the one combined. Okay, I have here the Ampest JP30, the Moricell. Look at this one. This one is cool. Moricell P30, EV30P. Look at the voltage in the Ampest JP30. It's just a beast. Under the same current. This is discharging at 30 amps, which is the maximum for. Let me see what else I have here. Temperature. Look at how cold works the amps, the JP30 next to the other ones, the Monicel, and the EV30P. Remember, the 30P is like kind of the old model. It's not the 30PL. PL is the new one that is coming, so it's not out yet.
Oh, that'll be nice.
Yeah, there's few interesting here, but I have even more. Maybe let's see. I want to see the data from. Let me
Yeah,
see
there's
what.
some the possibilities for like really high power but small and compact like battery packs, even just with stuff like the 50 PL. It's pretty crazy.
Man, no, that's another level. I don't have see the 50 PL here in these ones. I have the back. The other one is JP40. See,
Hmm.
comparing that's temperature. The back each is know that it run little bit. It's not too much. You see the difference in temperature. I mean,
Yeah.
but which one is the capacity over the time? Let's see, which one is that one? JP40 back 40 amps discharging, and this one is what power. Yeah, see the. I mean, we know JP40 is pretty powerful. Uh, this one is the current that should be linear voltage. That's the sag. Compute testings here. See, I mean, I never released some of this data. I mean, because honestly, some of that data is. Let me see what is this one's. This one is cool. I have the next one without color. This one is temperatures. Yeah, temperature. See the highest one, Molicel P50B, higher temperature. Next, it's just a tablets. They're beast. I mean, the tablets is just beast. Uh, Power. Look at how close they are. All the tablets in power. Yeah. So
Such a big jump in power.
yeah. I mean, I'm telling this. This one is the back. No, no. This one is the P50B. Yeah. Look at that. Under 40 amps. Under 40 amps, the Molicel give you 4578 milliamps. And the watts hour, this is what mattered, 14.5. And then if we see the same graphic in the, let me see, in the back, under the same load, let me see. Look at this. 14.53. That's the back. You see what I'm talking about?
Yeah.
Uh, Watts hour, and then and the capacity is insane. You know what? That's the software that is gonna cut the transmission because this is the free version, and I guess I have a time limit.
Nope.
So I'm gonna have to cut the streaming. So man, there's a bunch of going on, interesting. I mean, I love the
Exciting
cell.
times.
Yeah, and the 50 PL. God, good lord, I cannot wait for that, man. The 50 PL to see those numbers. I mean, with people with
Yeah,
packs and all that. I mean, it's gonna be very, very, very interesting.
yeah. Like Michelle in here earlier, I'm making a pack for them that's 15 amp hours, 72 volts, and it's with 50 PLs. So
And that's only what
it's
3P.
3P.
Yeah, 3P.
There's 60 of those cells in there, and it'll do like, theoretically, there might, theoretically would be able to do like 150 amps. So I think
Yeah, yeah.
there'll be
I
some
mean,
thermal issues.
hey, you need to use a lot of copper.
Yeah,
You need to use
let's
a
see
lot
what
of
I
copper.
can do. They're not gonna be able to. Let's see if they pulled 150 amps from it, they would get like 3 minutes.
Buddy,
So,
buddy, you guys are watching the screen yet? No, let me share
uh,
your screen. I want to show you something. Let me go to Facebook. All right, my models. Let me go here. Let me approve this person. He's trying to join. Uh, Let me show you something that Steven posted some time ago. Let me see the member, Steven. Um, you know this guy, right? Steven, one of the group members. He's great, man.
yeah.
Let me see the test that he did in a live to the 50 PL. Very interesting test. That was live, man. Let me see where is. I guess that was the day he made this live, and he was pulling. Let me see. I guess he pulled 160 amps from single cells,
The 50 PL is what made me first look into the PCM kind of stuff because
and that was insane. He did it live. The video is here. Let me see if I can find it. I guess it was after this.
hmm,
He made the live video. Probably it's one of these ones. Let's see. See, that's how he connect the thing. He was calibrating the equipment with that to make sure the clamp is able to to transfer all the. Let me see if we can see how much he's pulling here.
yeah.
172 watts at that moment. That's nothing. he was he was pulling over 400 in one point. Let me see if it's
Yeah,
one point he was pulling. I mean, that was insane. The numbers he was pulling from that cell. Uh,
that's really
See that was
crazy.
the testing he was doing. But you need
Wow.
to we need to see those testings that he was doing live.
Yeah.
I mean, March have a testings in the Patreons. Okay, now that the people are here, if you are you guys in Patreon, all of you guys?
And
No,
Facebook thing, I think.
it's my printer. I'm gonna share something here. Let me copy this, guys. Take this. Let me stop sharing this to take out the copy this. Whoever doesn't have Patreon, copy that now and take one free month. I mean, you will get a free month with that link. Create that account and you can join Patreon for free for 1 month
Nice.
using that link. Let me know it still works. I have three more. I bought like 25 spots that I still have a bunch of them available if someone wanna claim. Click that out, and you can create a free account. And is the link can be used 5 times. Please use it only once. If doesn't work, let me know. I can put another one.
All right. I think I got that.
Ah, look at who is here. Hayes Industries. How you doing, man? Thank you.
I gotta go, I think. It was fun.
You got
Thanks for
it?
the info too. Yeah, I think I'll check later, but I gotta go anyway.
All right, man. Hey, thank you for joining.
Yep, thanks. Fun
All right, man. See you
discussion.
later. I'm gonna remove you from here then. All right, he left. So if someone want to join just like him, you can use the a link I'm gonna provide later. But anyway, I have to, man. I have to go and eat something. Work with the boss bar. I have to do some shippings, a few orders and stuff like that. Thank you for people joining the live. Honestly, uh, I appreciate people that has been supporting the store. I really, really appreciate that. Let me put you uh, some links from the store. I don't know if this is gonna show. Oh yeah, this still works. I mean the software. So I appreciate the people that support the store. The website is there for the store. Uh, like the video if you like it. Subscribe to the channel. Click the notification bell. I mean, so when I go live, you can get the notification. And subscribe to the Facebook group. And again, the link that I post. Let me see. Where's the link? If you haven't subscribed to the March Patreon, get click that link and make a free subscription for 1 month. I paid for that already. That link is good for 5 persons. If it's not working the link, let me know. I put another one so you guys can get everybody that is here can get a free subscription to much Patreon. um, Again, thank you for synchronizing. I have to go, man. I'm hungry and I have to do some stuff here. So again, I'm gonna try to connect. I'm trying to my best to do now very often, every day, and share more content. I mean, and jobs that I'm doing, and the 50 PL is coming. Let me give you the last update for the people that doesn't. I mean, just synchronize. The EV50PL is already in California. It's in the California port. It arrived on the 21st and is right now waiting to be released from customs. So that can happen any moment. It can happen in 1 week. It can happen in 2 weeks. I mean, I don't think it's going to take that long, but who knows how busy they are. But again, I mean, I can receive tonight a notification from FedEx. Hey, we have the sales. So, and that means that custom released it, obviously. And then once I receive that notification, usually only take 4 days for me to receive the sales. That's a good part. So normally it's on Tuesdays that I receive the sales, and sometimes Mondays, sometimes Tuesdays. So I'm hoping that they send me that. Well, today's what, Wednesday. Between tomorrow and Friday. If that happened, then they are coming on Thursday. I mean, let's see. I'm crossing the fingers. So anyway, I removed the sales from the pre-orders, and the price went up because the offer was for the people that put the pre-orders. I mean, they have a special price. They wait and they pay ahead. There are people that pay 5 weeks ago and they're waiting. I mean, and I really appreciate that people that they has been waiting patiently. And I don't want to leave the pre-order for people that know that the sales is about to arrive because it's not fair for that people. Okay, that's not fair. So anyway, I'm not gonna have too many sales available for sales when they are in stock. I believe I'm gonna have less than 500 sales because I mean many people bought in pre-order. So, but there is gonna be, and I'm gonna save probably 50 cells not to sell in case someone need. I mean that from the people that bought a big batch and they need a little bit more cells for finish a build or anything happen. Yeah, I have to back it up. So after that, I'm gonna wait probably 1 month, hold those 50 cells, and then I'm gonna sell everything. So uh, that's the plan. But I'm gonna have maybe probably 450 cells for sale after they are in stock, which I hope is gonna be next week. Hopefully next week, if not the following week. I mean, I don't control that part. That's um, customs. Okay. So be patient. Be patient. Thank you. I'm gonna keep you updated. If you go to the website, let me share this now to show you what I'm talking about. Uh, I'm gonna show you quickly. If you go to my website, um, and if you go to the 50 PL sales, see, they are marked sold out. The price went up already, and I'm putting here, see, updates, pre-order close, update already in California port, waiting for custom to be release the shipment. All right, as soon as I know that they are released, and I have, because FedEx is gonna give me a date, I'm gonna post it here so you can keep an eye, the updates. um, Something new, I'm been working in the website, so for the people in Canada, if you click here, I cannot sell cells in Canada. If you see, there's no sales at all. But I mean, the rest, like welders, like BMSs, like accessories, they are available for Canada and as well for UK. So that's it's working already. If you are in UK or I mean or Canada, you can buy accessories. Many people are interested specifically in the flutes, the special flutes. So I can send that to Canada and UK. I cannot send to other places through the website because I'm limited in how many countries I can sell. My Shopify account only allow me to 3 countries. So in the future, I'm gonna be upgrading more to be able to sell through the website to more countries. So let me stop sharing this. Um, but if you send me an email, I can send you like a quote, and we pay by PayPal and stuff like that, and I can ship to other countries. I mean that in that way we can still do it. It's just by the website I'm limited to 3 countries at the moment. Probably in 2 months or maybe less, I'm gonna upgrade that. The thing is that have a cost, and I'm talking that cost me like $250 monthly just that upgrade versus the one that I currently have that I pay like 50. I need to justify that, to make that investment. To be honest with you, it's too much money. Um, anyway, thank you for synchronizing. You have a good night. Again, notification bell. Thank you for the people supporting the store, the Facebook group, and all that. And thank you until the next one. Okay.